questions on the homework on vertex form because it's easy. You love it. A, H, and K. But they don't all come that way. And one of the things that we learned we could do in the last section was we can use educated cheats to kind of work our way around and get things into vertex form. But the first thing we have to do is figure out what are the important points. So when we get a standard form equation of a quadratic, what we have to do is figure out where is this H and K business. You know, if I'm going to make this into vertex form, I could do that. Or I can just say, you know what, I'll just learn both forms. I'll learn vertex form, I'll learn standard form, I'll just treat them a little bit differently and things will be okay. And that's what we tend to do. So with standard form, the graph of f of x equals ax squared plus bx plus c. This is called standard form of a quadratic right here. Where a is not 0, because if a were 0, it would be a line. We talked about this the other day. If a is 0, you don't have an x squared term. That is not a quadratic anymore. It's not a parabola. That is a parabola. Now, parabolas are one of those things you spend a lot of time in exponential algebra and in Algebra 2 on, and that's because we have this thing on Earth called gravity that makes parabolas apply to a lot of situations. If you throw something into the air, it doesn't keep going forever. It has a parabolic path, and it comes back down. So there's a lot of application to parabolas. If a is greater than 0, we already know. Going to open up. That's not a shocker. Talked about that with our vertex form. If a is less than 0, we're talking about a negative number, and it's going to open downward. So positive versus negative, we already know about that. But our vertex is not going to be found by HK because this isn't in that form. You don't see an H or a K anywhere in standard form. So the vertex is a pretty important point. I mean, when we were talking about maximizing area in that homework problem, well, you have to find the vertex. That's what you need. So for this one, we say, all right, let's just figure out where the axis of symmetry is first, because the axis of symmetry always goes through the vertex. So our axis of symmetry comes from this little formula, x equals negative b over 2a. And again, I'm sure that'll come back to you if it hasn't already, because you spend a lot of time on that in exponential. The x-coordinate to the vertex is this, because remember, we're karate chopping that vertex to get our axis of symmetry. So really, when you use that little negative b over 2a formula, it's a 2-for-1 special. You know, not only do you get the equation for the axis of symmetry, but you get the x-coordinate for your vertex. So then we think, okay, I've got the x-coordinate. I really like the y-coordinate. Well, that's what this formula is for. We put x's into this and we get y's. So if we have the x-coordinate, we'll go ahead and put that x-coordinate into our equation, and that will give us our y value. Notice that's in function notation there. We're saying f of negative b over 2a, which means we're going to take negative b over 2a and we're going to plug it into the original equation. So then we'll have our vertex. The y-intercept is 0, c. When you think back to lines, it was always the constant, and the constant when we did y equals mx plus b was b. So your y-intercept was always 0b. But in this case, our constant is c, and that's still going to be our y-intercept. So our y-intercept is 0c. So focusing on a different set of information, but the vertex is always important. So no matter what, we're going to try and find that. So if we have an upward opening parabola, a greater than 0, our axis of symmetry comes from that little negative b over 2a. So does our vertex, but you have to do more work to get it. So you take that negative b over 2a, you put it into the formula, and that gives you your y value. And then you can find one easy point by just saying, hey, 0c is always going to be on my graph. And then use symmetry to reflect that. Now, sometimes that's enough. Sometimes you can draw your parabola just from having the vertex and the y-intercept, but sometimes they're just too close and you can't get an idea of how wide your parabola is. So especially on a test, I would go ahead and just make an XY table with like one other number. You know, in this case, I would be really tempted to put in 1, 2, 3. Because that would give me a better picture of exactly what the parabola is doing. Same type of situation over here, except we're looking at a downward opening parabola, but the process is the same. We use that negative b over 2a to figure out where's the axis of symmetry, where is my x coordinate of the vertex, put it back in the formula, get y, and then use 0c. Again, you may have to put one more point into that formula in order to see exactly how all of this works. So, graphing a function of the form y equals ax squared plus bx plus c. I always think this just takes so much longer than vertex form. It doesn't once you get used to negative b over 2a, but it's just kind of putsy. So, you identify your a, b, and c because you're going to need those for your formula. You find the axis of symmetry by x equals negative b over 2a. Pretty important little formula there, negative b over 2a. Once you have that x coordinate, you plug it back into your original equation to get your y value. So you carefully put it in, follow the order of operations, and get a y to go along with it. Then you need to find some other points. Sometimes 0c is enough. You know, sometimes if you use symmetry for that 0c, you actually get a good idea of the spread, the width of the parabola. But usually, you're going to have to plot at least one other point. You know, and like it says, option 2 would be use an x value that's reasonably close to the vertex. You know, with parabolas, they go up pretty fast because they deal with powers. You probably don't want to pick one that's like 10 because your numbers are going to be huge and you're not going to want to graph it. So stay reasonably close to the vertex and then just sketch the curve. You know, that's what we do. So no easy way out with these. You know, there's math you have to do to get to this piece. And like I said, we learned to love vertex form, but once you do enough of these, it feels natural too in standard form. So let's see what they want us to do. What is the graph of y equals x squared plus 2x plus 3? So we remember standard form is that y equals ax squared plus bx plus c. And we realize that if there's not a number in front of x squared, it's because it's 1x squared. And b is a 2, because the 2 is in front of the x term. And then our c value is going to be 3. That's our constant hanging out in that. And then step 2 is use that little negative b over 2a formula and get that axis of symmetry. So in this case, it's going to be negative 2 over 2 times 1, which is going to be negative 2 divided by 2, which is negative 1. Now we want to take that negative 1 and plug it into the equation because we want to know what do you get for y. This is already the axis of symmetry. So you might want to stop right there and say, okay, I know my vertex is somewhere on here. Not exactly sure yet, but somewhere. Somewhere on there. And that kind of gives your brain a little, oh yeah, that's right, I've got to figure out what the y value is. So we need to go back and put negative 1 into this fabulous little formula right here. And then just follow the order of operations. So we do the powers first. This would give us 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. Negative 1 plus 3 is 2. So our y value is 2. So putting together our x value of negative 1 and our y value of 2 gives us our vertex, negative 1, 2. So there it is. Now we're hopeful that if we just do 0C and use symmetry, this will show us enough of the graph. So we go back up and see that C was 3. So 0, 3 is definitely a point on our graph. And then we realize because of symmetry, negative 2, 3 is also going to be on our graph. That's not enough. And it's just not. We're not getting a good look at the spread for this one. So I think, you know what, I'll just stick kind of close and maybe put in a 1 or a 2 into this thing and see what I get. If a 1 gives me enough of the spread, then I don't need to do a 2. So go back up to the original, plop a 1 in there. And see if that spreads this out enough for us. So 1 squared plus 2, 1 plus 2 is 3, 3 plus 3 is 6. So at 1 we get 6. I would say that's enough. If we use symmetry on the other side, that gives us a pretty good idea of the width of this gravel. So there it is. It's just a lot of steps. But if we remember, start with that negative b over 2a. It doesn't take us too long to figure out how to graph in standard form. So step 5 was, I want to have it on the same screen that you guys could see, but this was where I said, you know what, let's just go ahead and put a 1 in there and see what we get. If I had put a 2 in, chances are possible I would have been off the grid. So sticking close to that vertex worked, and we got what we needed. All right, so here's the got it. The got it is, what's the graph of y equals negative 2? Oh my, did you guys get the squared on yours? Is there a squared in your packet? Ooh, smartboard's having a glitch here. Alrighty, let's go through it. I'm going to want to know what A, B, and C are. Maddie, why don't you identify those for me? What are A, B, and C? Okay, sounds good. Now we need to do the negative b over 2a. So go ahead and do that. Find negative b over 2a for me. And I'll call on somebody to help us out here. DJ, what did you get for the x there? X equals? Oh, yeah. Riley, you're looking done. 1/2. Not a bad fraction. Yeah. Step 3. What do we do for step 3? Alex, what do we have to do to get step 3? Plug it in, yeah. And since this one's a fraction, maybe you just want to grab your calculator and touch it in. I mean, it's not a horrible fraction, but most people don't like to deal with fractions as you go through there. So, negative 2 times 1/2 squared plus 2 times 1/2 minus 5. So negative 4.5. Again, I'd rather not write with decimals, so if you don't know that that's negative 9/2, you could always hit your little math button to get that. So now we know where our axis of symmetry is. It's at 1/2. We know where our vertex is located. That's going to be at 1/2, negative 4.5. And we realize, hey, 0c, that's going to be -5. And that means 1, -5 is on there by symmetry. And this time it's really obvious. That's not enough, you know? And they're all clumped together in that little bitty fraction mode there. So I think, well, 1's up there. Maybe we ought to just try 2. So we go back up and see what we get with a 2 in here. So you follow the order of operations. 2 squared is 4. -2 times 4 will be -8. This is 4. -8 plus 4 will be -4. -4 minus 5 is -9, and that is good news. Use symmetry, equal but opposite on the other side, and the reason that's good news is because that gives us a pretty good look at the width of this parabola. So we shouldn't have to put any more plates in. So even with fractions, this isn't awful. We have graph calculators. If we don't want to deal with the fractions by hand, we don't have to deal with the fractions by hand. We'll plug them in there and make this go really fast. As fast as vertex form? Absolutely not. You know, but we can do this math. So, oh, that's it? Well, let's at least fill these in. We have to like this. Well, let's at least fill these in. Vertex form, we already know. Y equals A. Parentheses x minus h squared plus k. Love that one. Vertex is hk. We graph these by first just getting our parent function with A and then just counting to move it. That's what we do. Vertex is hk. But often if it's a word problem, this vertex is probably our answer and we won't need to go any farther than that. But our standard form is y equals ax squared plus bx plus c. And we have to do a little bit of work to figure out where that vertex is. So I'm going to scoop this up because I can see some people are having trouble. I can see in the back. So I'm not being alone. So it says vertex is, and there's a blank. How do we get the x-coordinate again? -b over 2a. How do we get the y? Yeah, you have to put that back into the function, and the notation way to do that is f of -b over 2a. That's a really good way to see, hey, I've got to take the function, I have to push this back in there, substitute that in there in order to get that. So now, just thinking ahead to tomorrow, if we can find this using these methods, would we be able to use the cheater's way and write this in vertex form? Sure we will. Sure we will. So we're not completing the square yet. We're getting there. We're still using the cheater's way of making this happen. Oh golly, that was a lot shorter than I thought it was. So 4, 3, 2, 1, hopefully no zeros. Graphing the quadratic functions in standard form. Raise your hand if you honestly remembered that -b over 2a right away when you saw it. It's usually one of those things where you're like, okay, I knew that at one point, but now it's not. So, no, you guys are going to do fabulous with this. Bless you. I thought this lesson was longer. I would have had you do that second one with the candy partner. Oh, that's how that mistake got made in there. They must have cut some of the things. That's where my little square disappeared. obviously we want to limit the use of the graphic calculator right now. Don't want you just plopping these in unless you're checking your answer. We need to see all the math. We need to see the x equals negative b over 2a, see the axis of symmetry, see that you use the 0c point, y-intercept is included. But there it is. I'm guessing you'll make short work of that.